Okay, so starting with module 2 of cloud computing. So this is about parallel and distributed systems. So let's see ki what is parallel computing and what is distributed computing. Okay, तो parallel computing जो है that refers to कि एक process है. The process is divided into, or let's say a task is divided into processes, and all the processes are executed concurrently using a multiprocessor system. Okay, so this is parallel. This is the core idea of parallel and distributed computing. But a parallel computing में homogeneity of components होता है. That means जी जो भी मैं processors use कर रहा हूँ, all the processors are of same type and same capacity. Okay, and there is a shared memory which is accessed by all the processors. So this is about parallel computing. Distributed computing में क्या होता है कि जो हमारे प्रोसेसिंग एलिमेंट्स हैं या प्रोसेसर्स हैं दे कैन बी हेट्रोजेनस, दे कैन बी ऑन डिफरेंट नोड्स, दे कैन बी ऑन द सेम नोड, और दे कैन बी cores of the same processor. So there is heterogeneity in the processor type and capacity. Okay, so this is the major difference between distributed and parallel computing. Now, let's see key what is parallel computing in detail. So, we know कि parallel computing में homogeneity होती है. Now, parallel computing can have four types of system: SISD, SIMD, MISD, and MIMD. Okay. So, SISD क्या है कि single instruction, single data stream. So, एक single instruction stream आ रही है and एक single input आ रहा है. So that input पे वो जो instruction stream आ रही है, the processor uses that instruction stream on the data stream and output is given out. So this is simple SISD. इसमें sequentially process होगी हमारी instructions, correct? एक बाय वन करके. तो इसमें जो हमारी instructions है, data है, they need to be stored in the primary memory, and then example is IBM Macintosh. Okay. Now comes SIMD. So SIMD में क्या है कि सिंगल इंस्ट्रक्शन मल्टीपल डेटा. सो एक ही इंस्ट्रक्शन स्ट्रीम है जो मल्टीपल डेटास पर यूज हो रही होगी. सो देयर आर मल्टीपल प्रोसेसर्स ईच हैविंग अ डेटा स्ट्रीम, एंड द सिंगल इंस्ट्रक्शन स्ट्रीम इज गिवन टू ऑल द प्रोसेसर्स. एंड हमारे पास जितने डेटा इनपुट्स थे उतने डेटा आउटपुट्स आ जाएंगे. सो दिस इज मोस्टली यूज इन साइंटिफिक कैलकुलेशंस एंड ऑल. ओके, सेम इंस्ट्रक्शन सेट होती है बट डिफरेंट डेटा स्ट्रीम्स होती है. Now comes MISD. So in MISD, multiple instruction and single data. Okay. So multiple instruction and single data means you have a single instruction stream. Okay. Sorry, this is for that one. Huh. So you have multiple instruction streams, right? Like this. And you have a single data stream. Okay. Single data stream and multiple instructions. So for to all the processors, a single data stream is given and different instructions are given to perform. So, for example, y is equals to sin x, cos x, and tan x. So, sin, cos, and tan are different instruction streams, and the data is same. Okay, x. So, this gives a combined result, that is the single data output stream. Okay, so this is MISD system. Now comes MIMD. So, multiple instruction and multiple data stream. Multiple instruction and multiple data. This one. Okay. So in multiple instruction, multiple data, you can see stream 1, stream 2, stream n, and different data inputs to the same processor. So each processor is having different data and different instruction. So it's like a collection of SISD, and then outputs are given out. So this is MIMD machine. Okay. Now MIMD machine is divided into two types, shared memory and distributed memory. So shared memory means कि all the processing elements are connected to a single global memory. Okay. So that those are tightly coupled. Okay. So they communicate using that shared memory only. Now, next is distributed memory. So for distributed memory, every processing element has a local memory. Okay. Every processing element is having a local memory. So they are loosely coupled, not dependent on each other. Because if the memory is same, then one will be updating, the other might be reading. So there is a dependency. So though in that case, they become tightly coupled. But in distributed memory, they are loosely coupled. And now the processes communicate because they have to be synchronized or coordinate among themselves. So they communicate through IPC, inter-process communication channel. So this is distributed memory. Now in shared memory is easier to implement than distributed memory, right? But in shared memory, if let's say there is a failure in the memory system, let's say there is a free pointer uh, or a leak, memory leak anywhere, so that might create problem to all the processors because they are sharing the same memory space. But in MIMD, this won't be the case because each is having their local memory. Now, isolation is given in distributed memory. Also, shared memory is less likely to scale, okay, because the addition leads to memory contention, correct? Now, there are different approaches to parallel programming. So, there are three approaches: data parallelism, process parallelism, farmer and worker model. Data parallelism में क्या होता है कि data is splitted into multiple sets and each is processed using different processing element. Process parallelism में process is divided into multiple threads and each is run on a different processor. Farmer and worker model में one processor is made the master, other processors are made the slave. Now it's the master jobs to assign uh, tasks or jobs to the slaves, and the slaves on completion inform the master, then the master accordingly gives them other jobs, and so on. These things are executed. Now, levels of parallelism. So depending on the code ka size, called grain size, there are different levels of parallelism. So there is large grain, medium grain, okay, then fine grain and very fine grain. Okay, there are large grain, medium grain, fine grain, very fine grain. So what is large grain? Large grain मतलब कि हमारी task है सबसे पहले. So task is the largest grain. Then comes control level. कि conditional statements आ गई. मतलब सॉरी कंट्रोल लेवल में हमारी functions आ गई, methods आ गई, procedures आ गई. Okay, so those are medium grain. Then comes the data level. Data level में comes loop, conditional statements, instruction block. So these are fine grain. And then very fine grain में comes instructions. Okay. So in large grain, complete task processes come. Medium grain, function or procedures. Fine grain, loop or instruction block. And very fine grain, instruction. So now these process will be parallelized by programmer. Correct? Function will be parallelized by programmer. लेकिन loop or instruction block will be done by compiler and instruction will be done by processor. So these are levels of parallelism. These are the processes communicating through IPC messages. Task 1, task 2, and task 3 divided into functions having shared memory. Okay, this is medium level parallelism. Then blocks or loop, third level. And then at last instructions that are the final level. This is parallelized by programmer. Programmer fine level is done by parallelized compiler and very fine level is done by processor. Now, what is distributed system? So distributed system is a collection of independent computers. Okay, independent computers, but it is represented as a single system. Okay. Now, uh, in yeah, one more thing. There are some laws of caution. If you increase the cost of your system, okay, so your speed is proportional to square root of the cost. So at a point, increasing cost very much will not increase the speed by that much. You can understand the square root relation. If we have 25 ka square root, so speed is 5. If we have 36, the speed is 6. But as the square root keeps on increasing, let's say it goes to a very large value, uh, then let's say 625. So 25 will only be the speed. So this relation will look something like this. And then the second thing is key speed and the number of processors. So speed increases as log of the number of processor. Y is equals to k log n. Okay, so there is a logarithmic graph. Now distributed systems मतलब कि बहुत सारे computers हैं and they are represented connected and represented as a single system. Okay, the computers are connected to network anyways and message passing से they communicate. Now, what are the components of a distributed system? So hardware, operating system, middleware and applications. Correct? So hardware में क्या क्या आएगा? See, this is the layered distributed system and this is cloud computing distributed system. So हार्डवेयर में आ गई जो भी हमारी स्टोरेज है नेट नेटवर्क डिवाइसेस है computer hardware and any physical infrastructure. Then on the top of that, operating system sits. Operating system manages communication, IPC, process key scheduling, resource management, okay, and all. Then there is a middleware. Now this middleware gives a layer of abstraction over the underlying infrastructure of hardware and operating system. So what middleware does is कि जो भी हमारे गेस्ट होंगे या anyone who will be a user of this distributed system, he won't be knowing कि operating system जो existing है and hardware जो existing है, they don't have anything to do with that. Middleware provides a layer of abstraction or kind of virtualization. Okay, it gives a virtualization layer to provide customization to the user. Now, see, it hides all the heterogeneities of the bottom layers, correct? So they are just concerned with the services that they need to use using the middleware. Now comes cloud computing की distributed system. So for cloud computing, hardware and OS is combined together to give infrastructure as a service. Okay. Then the middleware is platform as a service. That is the runtime environment जिस पे हमारी एप्लीकेशन की एग्जीक्यूशन होगी. Okay. So no need to have anything or have any concerns with the infrastructure if we are using the middleware. And then comes SAS. So you all know कि SAS क्या होती है. The core logic is then implemented in the middleware that manages the virtualization layer. Correct? Now, architecture styles होती हैं कुछ. So architecture styles are basically कि components होते हैं and connectors होते हैं. So how those components and connectors interact, okay, or how they are styled out with a few constraints on them, how they are combined to form an architecture is architectural styles. So there are two types of architectural style. One is software and one is system. Software is the logical organization, okay, and system is the physical organization. So software is the logical organization and system is the physical organization. सो कंपोनेंट्स एंड कनेक्टर्स क्या होता है? सो कंपोनेंट इज नथिंग बट functions, okay, or any features of the system. And connectors are the communication uh, mechanism between the components. So there are different software architectural styles. So one is data centered, then comes data flow, then virtual machine, then call and return, and then independent components. So data centered क्या होती है? Data centered में data is the fundamental element and the core characteristic of data centered is accessibility to data. Okay, accessibility to data is the core characteristic of data centered architecture. Now data centered में repository architecture style होती है. Repository architecture style में क्या होता है कि there are two things. एक central data structure जो current state represent करता है system का एंड एक इज अ कलेक्शन ऑफ इंडिपेंडेंट कंपोनेंट्स जो उस सेंट्रल डेटा पर ऑपरेट करते हैं. ओके, एक सेंट्रल डेटा स्ट्रक्चर होता है दैट इज द करंट स्टेट ऑफ द सिस्टम एंड देन देयर आर कंपोनेंट्स. व्हाट आर कंपोनेंट्स? फीचर्स, ओके, और फंक्शंस दैट ऑपरेट ऑन सेंट्रल डेटा. अब इसके दो एग्जांपल्स हैं, डेटाबेसेस एंड ब्लैकबोर्ड. सो डेटाबेसेस में क्या होता है? डेटाबेसेस की डायनेमिक्स है कि द कंट्रोल, ओके, द कंट्रोल इज विथ the independent components. Okay, the independent components have the control in databases and they do some operations on the central data center or repository. Okay, so जो independent components हैं that trigger a few processes or operations जो data पर operate करते हैं. But blackboard में क्या होता है? Like if there is a blackboard and there are many candidates using the blackboard, so each one write few thoughts. So first, these are the knowledge sources. कि जो भी लोग blackboard use कर रहे हैं, they are giving knowledge. Okay. Then the blackboard represents एक data structure हो गया blackboard, which is storing the knowledge from different sources. So that is the knowledge base. And then control. So the control governs the interaction or the procedures that govern the interaction with the blackboard. Okay. So that is control. जो भी functions फिर उस blackboard पे यूज ऑपरेट होंगे एंड विच विल अपडेट द स्टेटस ऑफ जो भी नॉलेज बेस उस ब्लैक बोर्ड के पास है, दैट विल बी द कंट्रोल. ओके, सो दिस इज डेटाबेसेस एंड ब्लैक बोर्ड. एंड ब्लैक बोर्ड में क्या हो गया? डेटाबेसेस में इंडिपेंडेंट कंपोनेंट्स had the control. In Blackboard, the data store, central data has the control. Okay. Now comes data flow architectures. Okay. So in data flow architecture, the core characteristic is availability of data. Okay, core characteristic is availability of data. In data centered, it is accessibility to data, and in data flow, it is availability of data. So इसमें फिर there are two types: batch sequential style and pipe and filter. So batch sequential style is one by one fashion में the data is the programs are executed. So एक input आया that is executed using the instruction set and given the output. Now that output is the input for the next set and so on it goes. Okay. So this was used in mainframes. Now comes pipe and filter. So pipe and filter में क्या होता है कि pipe is the sorry, filter is the component and pipe is the communication between components. So pipe is the connector. Now in this data is processed incrementally, but एक filter के पास जैसे data पहुंचेगा, the filter will start processing it, okay, and give the output. Now the filter gives output and to whatever next filter it is connected with using the pipe. So that output acts as the input stream for the next filter. Okay, and so on. This process continues. So this provides concurrency, unlike batch sequential style, जहाँ पर one by one करना पड़ता है. Okay, so there are in-memory data structures such as FIFO. Okay, that is a queue which handles all this. So this is called pipelining. Now comes virtual machine. So virtual machine में क्या है कि abstract execution environment create हो जाती है. Okay, that simulate whatever hardware software environment you would like. Okay, any features that are not in the current hardware software, you can simulate that using an abstract execution environment, is what is the characteristic of a virtual machine architecture. Now, virtual machine architecture B is of three types: rule-based style, interpreter style. Okay, it is of two types: rule-based style and interpreter style. Now, what is in rule-based style? So, rule-based style में एक इन्फरेंस इंजन होता है. ठीक है, एक इन्फरेंस इंजन होता है. जो प्रोग्राम्स है वो इंस्ट्रक्शंस की तरह होती हैं. ओके, प्रोग्राम्स आर इंस्ट्रक्शंस एनीवेज, फॉर्म ऑफ रूल्स, एंड देन इनपुट डेटा जो है दैट आर फैक्ट्स टू द इन्फरेंस इंजन. और इन्फरेंस इंजन के पास फैक्ट्स है, इन्फरेंस इंजन के पास प्रोग्राम्स है एज इंस्ट्रक्शंस. सो इन्फरेंस इंजन गिव्स द आउटपुट. ओके, नाउ जो हमारी प्रोग्राम्स है, दैट इज द सेट ऑफ रूल्स that identifies the knowledge base जिसको query करना है to know about the system. So rule based style expresses a system in terms of its behavior rather than the components, because the set of rules identifies the knowledge base that can be queried to infer properties about the system. So इसकी example हो गई sensory data activating alarms. कि let's say a water tank is filled, so the sensor activates and gives an alarm to you. Then network intrusion detection system. So senses an intrusion, gives an alarm to you. So these are rule-based style. Now comes interpreter style. Rule-based style में जो हमारी abstract execution environment है, that is an inference engine. Interpreter style में a pseudo program is expressed in interpreter co-acceptable format and it is interpreted. ओके, सो इसमें कुछ नहीं है, प्रोग्राम को इंटरप्रेट करते हैं. इसमें इंटरप्रिटेशन, सो इसमें बेसिकली फोर कंपोनेंट्स होते हैं. एक हो गया इंटरप्रिटेशन इंजन, ओके, जो इंटरप्रेट करेगा. सेकंड हो गया इंटरनल मेमोरी, जहां पर हमारी सूडो कोड है. Third is the representation of current state of the engine, and fourth is representation of current state of the program. So एक interpretation engine हो गया, एक memory हो गया जहाँ पर pseudo code है, एक हो गया जो प्रोग्राम का करंट स्टेट रिप्रेजेंट करेगा, एंड एक हो गया जो इंजन का करंट स्टेट रिप्रेजेंट करेगा. So this is basically used for high level programming languages के लिए virtual machines बनाना, like Java, etc. वर्चुअल मशीन से परफॉर्मेंस लो डाउन होता है. नाउ कॉल एंड रिटर्न आर्किटेक्चर. सो कॉल एंड रिटर्न आर्किटेक्चर इज मेथड कॉल्स पे बेस्ड. इसकी कैरेक्टरिस्टिक क्या है? इट इज बेस्ड ऑन मेथड कॉल्स. इसमें टॉप डाउन स्टाइल है, ऑब्जेक्ट ओरिएंटेड स्टाइल है, लेयर्ड स्टाइल. टॉप डाउन स्टाइल क्या है कि एक टास्क है दैट इज डिवाइडेड, डिवाइड कंकर अप्रोच यूज करेंगे, डिवाइड टू स्मॉलर टास्क. नाउ द स्मॉलर टास्क एग्जीक्यूट. Now the communication happens using RPC, remote procedural call. Okay. तो सब प्रोग्राम्स कॉल है, सब प्रोग्राम्स ने कुछ आउटपुट रिटर्न किए दैट इज गिवन टू द प्रीवियस वन, लाइक इन अ फॉर्म ऑफ अ ट्री. जो भी होता है दैट इज टॉप डाउन स्टाइल. नाउ ऑब्जेक्ट ओरिएंटेड स्टाइल. ऑब्जेक्ट ओरिएंटेड स्टाइल में we represent everything. The system is represented in form of classes and implemented as objects. So classes के पास क्या होगा? डेटा होगा, methods over, correct? So there is a coupling between data and operations. How? कि जो हमारे ऑब्जेक्ट हैं, ओके, उसके जो इंस्टेंसेस है, ऑब्जेक्ट इंस्टेंसेस जो है क्लास के, they will hide the internal implementation, but and protect their integrity. But they will also expose methods or operations which we can use. So this is the object-oriented style. Now comes layered style. So layered style is nothing. जैसे computer networks में we have OSI model कि each layer provides an abstraction. Each layer is independent of other layer. Each layer has a unique function. Okay, so we make up different layers to segregate the functions and provide abstraction at each level. Okay, so each layer provides a lower level abstraction and a higher abstraction layer. And protocols are used to establish communication between those layers. Like OSI में protocols use होते हैं. Now, in this case, generally आप higher abstraction layer से lower abstraction layer पे जाते हो या lower abstraction layer से higher abstraction layer पर आते हो. Okay, but generally this starts with the higher abstraction layer and it goes so on. For communication, protocols are used. Okay. Now, architectural styles based on independent components. Architectural styles based on independent components. So इसमें दो चीज है, communicating processes. Independent components में communicating processes हो गए, event systems हो गए. Communicating process, so processes are independent. They communicate using IPC. This is very much about communicating processes. The processes independently execute हो रहे हैं and they can coordinate using IPC. Now event systems में क्या है कि आप event handlers create कर रहे हो, आप collection of events publish कर दिए आपने, to which different components can register. Okay, and on trigger of that event, if that event is activated, then a callback is executed. Okay, so this is provided either at the API level or at the programming language level. So event systems make it easier to scale because new features can be or new modules can be easily integrated. But there is a disadvantage also. System पर control lose हो जाता है. Why? Because the system or the component जो एक event को trigger कर रहा है. Okay, एक event अगर trigger हो रहा है तो no one knows कि वो कितने सारे event handlers को invoke करेगा. Okay, so control lose हो जाता है system पर. So this is about independent components. अब सिस्टम के आर्किटेक्चर स्टाइल्स है. सो देयर इज क्लाइंट सर्वर. क्लाइंट सर्वर में एक क्लाइंट होता है, एक सर्वर होता है. क्लाइंट रिक्वेस्ट करता है सर्वर को, सर्वर रिस्पॉन्स भेजता है क्लाइंट को. दिस इज द सिंपल थिंग दैट हैपेंस. नाउ देयर इज टू टाइप्स ऑफ मॉडल्स इन दिस. वन इज अ थिन क्लाइंट मॉडल एंड वन इज अ फैट क्लाइंट मॉडल. सो थिन क्लाइंट मॉडल में क्या होता है कि डेटा प्रोसेसिंग एंड ट्रांसफॉर्मेशन का जो लोड है दैट इज ऑन सर्वर साइड. Thin client means client is thinner than the server. So the load of data processing and transformation is on server, and client has a light implementation that is just concerned with retrieving and returning the data. Okay, with no processing on the client side. Then fat client में क्या होता है? Just opposite of this. Client is also responsible for processing and transforming the data before returning to the user, and server as a light implementation. Okay, mostly concerned with the access of the data. Now, client server architecture mein, there are three major components: presentation layer, application layer, and data storage layer. So, thin client में क्या है कि client is thinner. So, client में सिर्फ presentation layer होगी and application logic and data storage server के पास होगी. फैट क्लाइंट में क्लाइंट के पास प्रेजेंटेशन होगी, एप्लीकेशन होगी एंड सर्वर के पास बस डेटा स्टोरेज एंड मेंटेनेंस होगी. ओके, नाउ देयर आर टू टीयर, थ्री टीयर एंड एन टीयर मॉडल्स. टू टीयर मॉडल में क्या है कि क्लाइंट प्रेजेंटेशन के लिए रिस्पॉन्सिबल है, सर्वर एप्लीकेशन एंड डेटा स्टोर के लिए रिस्पॉन्सिबल है। ठीक है, सर्वर एप्लीकेशन डेटा स्टोर के लिए रिस्पॉन्सिबल है एंड क्लाइंट प्रेजेंटेशन के लिए रिस्पॉन्सिबल है। नाउ दिस इज सुटेबल फॉर सिस्टम्स ऑफ लिमिटेड साइज एंड स्केलेबिलिटी इश्यूज है इसमें। ओके, सो दिस इज टू टीयर आर्किटेक्चर। थ्री टीयर आर्किटेक्चर में क्या है कि दीज थ्री लेयर्स आर सेपरेटेड इनटू थ्री टीयर्स। सो एक एप्लीकेशन होगा, लेयर होगा, एक प्रेजेंटेशन लेयर होगा, एक डेटा स्टोरेज लेयर होगा। नाउ कम्स पीयर टू पीयर मॉडल। ओके, सो अच्छा, एग्जांपल ऑफ थ्री टीयर इज वेब ब्राउजर के कोई भी वेब एप्लीकेशन इज एन एग्जांपल ऑफ थ्री टीयर। ओके, नाउ कम्स पीयर टू पीयर मॉडल। सो पीयर टू पीयर मॉडल में क्या है कि जितने कंपोनेंट्स है दे आर पीयर्स। ओके, so each peer has client and server both. Like in this, each peer in this network is having serving as both client and server. तो अगर उन्हें कुछ चाहिए, so they will send a request and they can also serve a request. They can either initiate a request or serve a request with a response. So they do both the functions of client and server as needed. So this is a highly decentralized architecture because there is no center of the architecture, center of control. Okay, everyone is doing everything. So this is a decentralized architecture and it can scale better with increase in number of peers. Disadvantages: management of the implementation of algorithm is more complex than client server. Correct. Example is BitTorrent. Now, file sharing application or peer-to-peer systems. Yeah. How? Let's say कि आप एयर ड्रॉप कर रहे हो अपने आईफोन से. So your iPhone can receive the file also. Your iPhone can share the file also. Both the things can happen. Okay. Now, models for inter-process communication. So inter-process communication के लिए we have models like shared memory. As we already discussed, shared memory हमारी MIMD में डिस्कस हुई थी कि एक ही मेमोरी है, all the processors are accessing those memory, so the processors can communicate using that shared memory. No need of communication because we are having a shared memory. Next is remote procedure call, and then there is message passing. There are also sockets. Okay, sockets is transferring a sequence of bytes which is converted at higher levels into a more meaningful representation. IPC क्या होता है? Exchange of data and information between processes. तो वेब सॉकेट्स क्या होता है? वेब सॉकेट्स जो है वो बाई डायरेक्शनल कम्युनिकेशन होता है, फुल डुप्लेक्स कम्युनिकेशन स्टैब्लिश होता है बिटवीन द क्लाइंट एंड द सर्वर. दिस फॉलोज एक्सक्लूसिव पेयर कम्युनिकेशन मॉडल. ओके, तो वेब सॉकेट्स में क्या होता है कि फुल डुप्लेक्स होता है, बोथ कैन सेंड ओके मैसेजेस एंड न्यू कनेक्शन की जरूरत नहीं है, लाइक क्लाइंट एंड सर्वर वेब सॉकेट कनेक्शन स्टैब्लिश हुआ एंड बोथ कैन जस्ट सेंड मैसेजेस. जो हमारी जो भी चैट्स में यूज होती है दैट इज वेब सॉकेट. नाउ मैसेज पासिंग में मैसेज इज द मेन एब्स्ट्रैक्शन. तो मैसेजेस को आप इंक्रिप्ट करके इनकोड करके एंड देन एक्सचेंज करो, तो दैट इज मैसेज पासिंग इंटरफेस. नाउ एक्सक्लूसिव पेयर कम्युनिकेशन मॉडल क्या होता है? कनेक्शन सेटअप हुआ, नाउ बोथ वे मैसेज होगा, फुल डुप्लेक्स बाई डायरेक्शन. देन पब सब कम्युनिकेशन मॉडल होता है. पब सब में क्या होता है कि एक पब्लिशर है. ओके, पब्लिशर है, देन देर इज अ ब्रोकर, then there is a queue. Okay, so this publisher sends messages to topics. So it creates topic, key topic one and topic two. Now there are consumers. The consumers can subscribe to this topic. कि मैंने इस topic को subscribe किया. So now I will receive all the things that are getting updated in this topic. And consumer 3 will get all the things that are getting updated in this topic. So let's say key a newspaper model. Okay, newspaper is published. Now there are different newspapers published by the publications. So you subscribe to, let's say, one particular magazine or newspaper. So you get daily updates on that particular magazine or newspaper. Okay. So this is publish subscribe communication model. Then there is push pull communication model. So push pull is here topics is created, here push pull. So in push pull, a publisher sends messages to queues and the consumer consume messages from the queue. So messages are pushed to the queues by the publisher and consumer pulls from the queues. So this is push pull. Okay. Publisher to notify all the subscribers, and pull strategy. In this case, the publisher makes available the message for a specific event. It is responsibility of the subscribers to check whether the message is available or not. Okay. Now comes request response communication model. So client सर्वर को रिक्वेस्ट करेगा, सर्वर जो भी मेथड्स एग्जीक्यूट करना है, फेचेस करना है, जो भी रिसोर्सेज उसे एक्सेस करना है, एक्सेस करेगा और रिस्पॉन्स बनाएगा एंड देन सेंड इट टू द क्लाइंट. नाउ कम्स रिमोट प्रोसीजर कॉल. सो रिमोट प्रोसीजर कॉल क्या होता है कि क्लाइंट जो है दैट सेंड्स अ रिक्वेस्ट की इन्वोक दिस पर्टिकुलर प्रोसीजर. ओके. देन द सर्वर executes that procedure and returns the response. Okay. So basically ये अगर RPC का सर्वर है एंड ये RPC का क्लाइंट है. So RPC का सर्वर is having many procedures registered in the procedure registry. Now the client says कि मुझे ये प्रोसीजर रन करके आउटपुट दो and it sends the parameters. Okay. So the parameters are, marshaled. There's a term called marshalling. जहाँ पे जो भी parameters है, जो भी data है, that is serialized. Okay, serialized in, let's say, JSON or protobuf format. And then it is passed to the server. A server के पास पहले उसकी अनमार्शलिंग होगी, देन सर्वर विल एग्जीक्यूट द प्रोसीजर, देन जो भी हमारी रिस्पॉन्स आएगी, द प्रोसीजर विल जो भी रिटर्न वैल्यू आई, सी अगेन उसकी मार्शलिंग होगी एंड देन इट इज अगेन ट्रांसमिटेड ओवर द नेटवर्क एंड दैट रीचेज हियर. नाउ अब रिटर्न वैल्यू की अनमार्शलिंग होगी एंड वी गेट द रिस्पॉन्स. सो दिस इज प्रीटी मच व्हाट आरपीसी डज. ओके. नाउ कम्स डिस्ट्रीब्यूटेड ऑब्जेक्ट. तो डिस्ट्रीब्यूटेड ऑब्जेक्ट क्या होता है? डिस्ट्रीब्यूटेड ऑब्जेक्ट इज कि हमारी इट फॉलोज ऊप्स प्लस आरपीसी की टेक्नोलॉजी. सो आरपीसी कॉन्सेप्ट एज इट इज एज एक्सप्लेन्ड इन आरपीसी, द सिमिलर आर्किटेक्चर यहाँ पे रहेगा, बस ऊप्स यूज हो जाएगा साथ में. सो यहाँ पे क्या है कि ऑब्जेक्ट की जो स्केलेटन है दैट इज ऑन द सर्वर साइड एंड जो उसकी प्रॉक्सी है मींस रेफरेंस दैट इज ऑन द क्लाइंट साइड. ओके. सो क्लाइंट विल से कि इस ऑब्जेक्ट पर मुझे ये मेथड कॉल इन्वोक करो. ठीक है. सो अगेन हियर रिक्वेस्ट विल गो एंड इस ऑब्जेक्ट की स्केलेटन पर दैट मेथड कॉल विल बी डन. ओके. वॉट एवर रिस्पॉन्स आएगा दैट विल बी गिवन बैक टू दिस. सो दैट इज डिस्ट्रीब्यूटेड ऑब्जेक्ट. Okay. So process registers a set of interfaces that are accessible remotely. Client process can request a pointer to these interfaces, invoke the methods available. The underlying runtime infrastructure is in charge of transforming the local method invocation into a request or remote process. Okay. तो उसने क्या किया कि ऑब्जेक्ट की जो प्रॉक्सी है उस पर लोकल मेथड इन्वोकेशन किया, बट एक्चुअली में वो लोकल मेथड इन्वोकेशन इज ट्रांसफॉर्म टू रिमोट रिमोट इन्वोकेशन. ओके. रिमोट प्रोसेस एंड जो भी रिजल्ट आया दैट इज रिटर्न बैक. ओके. कम्युनिकेशन इज थ्रू मैसेजेस. इसके एग्जांपल क्या हो गई? कोरबा कॉमन ऑब्जेक्ट रिक्वेस्ट ब्रोकर आर्किटेक्चर, component object model, COM, DCOM, and Java remote method invocation, .NET remoting. These are the examples. Now comes web services. So for web services, an implementation of RPC concept over HTTP. Okay, thus allowing the interaction of components that are developed with different technologies. Web service is exposed as a remote object hosted on a web server. And method invocations are transformed in HTTP request, opportunely packaged using specific protocols such as Simple Object Access Protocol or Representational State Transfer, that is REST APIs. So how REST API से communication कैसे होता है? So get, push, put, post and delete. Get, put, post, delete, patch. These are the five methods. So the HTTP client gives these in the form of these five. एक payload pass करती है that is a JSON or XML. Okay, and reaches the server. There can be an authorization. जो भी हमारी payload है, it takes that, it executes जो भी तुम्हें fetch करना है and returns that to the client. So this is basically what happens with REST API. Request response model use होता है. We give a request with a payload, we get a response. Okay. Now, service-oriented computing. So we know what a service is. Any function, any feature may it be a very simple thing or a very complex thing is a when exposed uh, is exposed as a service. Services are autonomous. They are independent. They are independent. They are loosely coupled. Okay, they are independent. They are loosely coupled. There is an abstraction. Service is completely independent. Okay. Then there is a contract, SLA, service level agreement. Okay, which is specified through the documents. Also, uh, boundaries are explicit. They are across different domains. They are autonomous. They share schema and contracts, not class or interface definition. Correct. Service compatibility is determined based on the policy. Now, there are two roles, the service provider and the service consumer. The service provider gives a service contract, it's the nature of the service, fees, requirements, quality of service is written. And the service consumer can locate the service in the registry and use it. Okay. So reusability, autonomy, discoverability, composability, and lack of state. So this is pretty much about module 2. Uh, there are a few things like Java remote method invocation and all. Yeah, DCOM and all, but that are mostly RPC methods only. So just a few terms to remember in all of those. Like for Corba, there is an object request broker. Okay, that handles everything. Like interaction between the skeleton and the proxy and all. Similarly in DCOM and in RMI. Okay. So this was about module 2. We will continue with the module 3 in the next lecture.